Struggling with GATE computer science? Find out the secret to crack it from the toppers.
Ravi sir was the one who crafted my success. His strategy of teaching concepts from scratch made my understanding so strong that I could conquer any question.
Ravi sir motivated me every day to keep going and keep learning. It is because of him that I overcame all obstacles in this journey.
I remember him saying, CS stands for common sense, and that one line completely changed my approach towards the subject.
Being a working professional, I didn't have to spend additional time figuring out what to study. Just watching Ravi sir's videos fully equipped me to crack the exam. The secret
To my success
In GATE is
Ravindra Babu Ravula Sir.
Many success stories, many more waiting to happen. Learn live from
Good morning everyone. So we were doing the revision series for C++ basics. So till now we have covered some of the basic features like control structures, and in pointers also we have discussed pointers, void pointer, dereferencing and null pointer. So we were at arrays. Okay, so we have to see what arrays are and what is the connection between a pointer and an array. So we'll cover one-dimensional array, multi-dimensional array and their connection with pointers basically in these slides. And before that we have a contest today at 9 p.m. So at 9 p.m. Second practice test for C++ is there. So it will have beginner problems, 3 or 4 beginner problems and a few advanced problems as well. So advanced, by advanced I mean from the basics only, but some logical thinking will be required in them. Okay, so you should attempt it. It would be 3-hour long contest, and the link to the contest is in the description of this video. Okay, so we'll discuss this contest tomorrow. Okay, so it won't be a long contest. You can solve all the problems in 2 hours, so you have a time window of 9 to 12. Okay, so you can start anywhere, and it won't take much time. Okay, you can solve it in 2 hours. Okay, cool. So let's start with arrays. So as we know from C programming, sequential collection of elements of same data type. So homogeneous data type, when we have a sequential collection of same data type, that is called an array. Okay, so that's the difference between array and structure. We'll see in structure there we can have different data types as well, but in arrays, what we call an array, when we have a collection of homogeneous data types. Okay, so we can access any element of an array in constant time by just indexing it. Okay, so for any type t, and then in square brackets when we write size is an array of type t of size array of size elements of type t. Okay, so the elements are indexed from 0 to size -1. C and C++ have 0 indexing, and here are a few examples. Here ARR is an array of size 2 of integers, or basically ARR is an array of 2 integers. P is an array of 4 character pointers. Okay, so how P will look like? You will have an array with 4 character pointers, so they want to point to some character. Fine. Yeah, so you can initialize arrays like this or this, right? So in curly braces, so you don't need to write size here if you are initializing it like this. So it automatically assigns an array of size 3 and initializes its value to x, y and z, and similarly in ARR. Okay, but here okay, cool. So what happens is when you are declaring an array of size 3, you cannot initialize it with 4 values. This is not correct. Okay, and when you are declaring an array of size 6, you can initialize it with 4 values. The remaining values will automatically be 0. So you can also write it like this: ARR to 6 equals this. So if you don't write anything, all of them will be initialized to 0. Okay, if you write only one value, first value will be 1 and remaining all will be 0. So this is allowed, and this is also not allowed. You cannot assign one array to another array like this. Okay, so the equality operator is not overloaded here. This is not allowed. Cool. So now we are gonna see the connection between pointers and arrays. So this is an array, and so what happens is the name of the array is equivalent to the name of the array is equivalent to the address of first element. Fine. So the name of the array can be used as pointer of its initial element. So when we write int v equals 1 2 3 4, v is basically the address to this one. Fine. So v is nothing but a pointer to the first element of this array. So we can assign v to some pointer, to some integer pointer as well. And so actually what happens is when we have an array, then the name of the array is equivalent to the address of the first element of the array. So these both things are same. Okay, so you can assign this to some integer pointer, you can assign a to some integer pointer. These are equivalent. So this is allowed, and also this is allowed. So this is pointer arithmetic. So when we do so actually a plus n is equivalent to address of a of n. Fine. So a plus 1 is equivalent to the first element's address, or basically the second element's address, because it's zero indexing. So this is also true. So you can also assign v plus 4 to some pointer. It will be the address of v of 4. Fine. Cool. So next we'll see multidimensional arrays. In a similar fashion, we can create 2D arrays, 3D arrays, and so on. So what a 2D array signifies, what a 1D array signifies, it is an array of 5 elements. So when we write this thing, so it's an array of 5 elements with each containing 3 elements. Okay, so it is like 3 arrays with 5 elements each. 3 arrays of 5 elements each. Fine. So the first, so MARR will point to the first location. So this is the first array, or MARR 0, and it contains 5 elements. And similarly MARR 1 contains 5 elements, and MARR 2 contains 5 elements. Fine. So MARR 1, 2 is like first row and second column, this element. Okay, so when you do MARR plus 1, so as I have told you, this will be equivalent to the address of MARR 1. So it will be the address to this memory location and not this memory location. Okay, so when you do when you increment an 2D arrays pointer, then you'll get to the next row, not the next column. Okay, so MARR plus 1 will point us to this location. So how many elements we have skipped here? 5 elements. Okay, so just remember this. Cool. So yeah, this is how you can initialize an 2D array, and here we are printing in the values up to that particular 2D array basically. Okay, so I hope this is clear. Okay, this is very important. So when you increment a pointer to a 2D array, you actually do not skip one integer, you skip one entire row. Okay, cool. Fine. So now so you can basically store a 2D array in 2 orders in the computer architecture. So one is the row major order and other is the column major order. So this is also very relevant to gate syllabus. Okay, so you might have read this thing. So all the elements in a 2D array. So the memory, your computer memory is sequential. Okay, so it is like one-dimensional memory only. So it is sequential. So you cannot store 2D things in your memory. So the 2D arrays have to be also stored sequentially only. So how we can store a 2D array sequentially in the memory? So that's where we have these 2 orders. Either we can store the first row and then the second row and then the third row and so on. This will be called the row major order. And or we can store column for first column and then second column and the third column. This will be the column major order. Okay, so now how we can pass arrays. So this is very important. Okay, so I have seen most of most of the students get mistake in this only. Okay, so passing arrays. So in the first try only you have to write the correct syntax for this. So do enough practice for this. Okay, so so we already know when we write an array int a5. So we know that a is what? The address of the first memory location of a of this array. So it is basically a is basically an integer pointer only. A is of type integer pointer only. And it contains the address of the first memory location of this address of this array. So how we can pass this array then? So we can have an integer pointer in some function, and we can pass a here. So let's say p. So now p will contain the address of the first memory location, and we can access all the elements of the array like p plus 1. Asterisk p will be the first element, asterisk p plus 1 will be the second element, asterisk p plus 2 will be the third element, and so on. Okay, so this is the first syntax basically to pass an array. Okay, we can have an integer pointer, and we can pass the name of the array to this integer pointer. Second is like same as in array only. So when we can write int and then argument variable name, and then we can write square brackets. So we can skip this value also. This and this both are fine. Okay, you do not need to pass the size. So these both of them are fine. So writing this and writing this is same if you want to pass arrays. Cool. Okay, so yeah, good morning Nitish. Yeah, cool. So this is how you pass 1D arrays. So let's see pointer to function now. Then we'll cover pointer to 2D arrays later. In the next slide we'll cover pointer to 2D arrays, how we can pass 2D arrays. That is also very important. Okay, so I hope you understood how to pass a 1D array. Fine. And now let's see pointer to function. This is also a very important concept. So like any variable or any object, function is also stored in some memory location, right? And we can have a pointer to that function, and that pointer will contain the address of the memory location where that function is present, the starting location of that function. Basically wherever the piece of code, the function is present in memory, the starting address of that particular memory location can be stored in some pointer, and that pointer will be called pointer to the function. Fine. So like any object, the code generated for a function body is placed in memory somewhere, so it has an address. So we can have a pointer to a function just as we can have a pointer to an object. The pointer obtained by taking the address of a function can then be used to call the function. Okay, so this is how you define a pointer to a function. So this look at the syntax very carefully. So how do you, what is the prototype of a function? You like write like this, right? Void fun int. Cool. And when you want to write a pointer to the function, you cannot just put an asterisk here, because then this asterisk will be associated to this void. So when you write like this, and you don't have brackets, this will be a function fun, not a pointer to a function. This will be a function fun with an argument int and return type void star. It returns pointer of some type. We know what void star is. It can hold memory of any data type. Fine. So what is this syntax? It is a function with an argument int and a return type void star. And if you want to declare a pointer to a function, you have to write like this. This is a pointer to a function which has name foo, which has argument int and return type void. Okay. Yeah, Rahul. Cool. So unmute. Cool. So this is how you create pointer to function, and this is so now we are gonna see some complicated syntaxes. Okay. So what do you think? What is this? So read inside out. Okay, from the brackets. Foo is a pointer to a function with argument integer pointer and return type void pointer. Okay. Foo is a pointer to a function with argument integer pointer and return type void star. Fine. Cool. So now how we can initialize a pointer to a function? So we have seen how we declare a pointer to a function, okay? And now to initialize it, we have to give address of some function to it, and the prototype of that function should match the prototype of this pointer to the function. So like it's like that, if a pointer to the function is having argument int and return type int, then you can assign it the address of any function with return type int and argument int, not some other function, okay? So the argument list and the return type should match. Then you can assign that particular function to this pointer to the function. So here the pointer to the function had an argument int and return type void, and this function fun also had argument int and return type void. So we can assign the address of this function to this ptr. And so someone is asking about void pointer. So I taught about void pointer in the yesterday's revision session. Basically what void pointer is, it can hold an address of any data type. So you can assign it an address of some integer variable or a float variable, anything, okay? So it is used when we don't know what type of data type we are trying to fit in. Fine. So yeah, this is how you can assign the address of the function fun to this pointer to the function, and also you can skip this and also. So this is also the same. So the function name is also equivalent to its address. Fine. So this is also fine. So both of the syntaxes are fine. Cool. So this is what a pointer to function is. And now after understanding pointer, what do we see next? Dereferencing that particular pointer. So that's why we created pointers, right? We want to use those pointers. So to use those pointers, like to see that what memory location they are pointing to and use that particular memory location, we need to dereference it. And yesterday we saw that to dereference any pointer we use star. So when you want to use this as a pointer ptr, pointer to a function, what you can do is write asterisk ptr. So this will be your function now. Asterisk ptr is same as fun. Asterisk ptr is same as fun. So now you can pass some argument like 5 and 5 will be printed. So fun 5 and asterisk ptr 5 are same. Okay. So we had this and we had this. So we assigned the address of fun to ptr. So asterisk ptr 5 is same, and also you can skip this ptr. You can skip this asterisk. The same way we can escape this and we need not write this and basically, okay? We can assign it directly, and in the similar way, so asterisk ptr and ptr will be same here. So this is somewhat new syntax, so you can just remember it, okay? There is no logical explanation to it, but yeah, ptr is also same as asterisk ptr, the dereferencing one. Cool. So then we did some practice questions, so I'll skip them for now. You can watch that video if you want to do some practice questions as well. Okay, so I am just you can just pause the video and try to do it on your own. Since we are in the revision series, we won't be covering the questions. So this question is what you often see in GATE, right? An array, 2D array is of size this many rows, these many columns, and you want to find the address of one particular memory location given the starting location is this. So we in the lecture series we derived this particular formula also for 2D arrays. Okay, so you can see that video. Cool. So then we covered some complicated syntaxes. Okay, so I'll get to the most complicated one, and we can do just one of them. Okay, so let's do this. Okay, so that will be a quick revision for this. And if you want more questions, see the 50 practice problems in C++ basics. See this video. Here we have covered 50 practice problems in everything in C++ basics. See this video or see the lecture video of this particular subject. Okay. Cool. So what is this? So X is an array of size 3, and what does this array contain? Pointer to function. So X is an array of pointer to function with argument int and return type void. So what is X? X is an array of size 3. Each element of X is a pointer to function. It wants to point to some function, and that function should have a prototype like this: return type int and return type void and argument int. Fine. And here X is a function. So remember, when we have brackets with asterisk, then X is a pointer to function, but here we don't have bracket. So X is just a function. X is just a function with no argument, but return type is what? A pointer. Return type is a pointer. Okay. X is a fine. X is a function with no arguments, and return type is a pointer to a function with no okay, sorry, let me do it again. X is a function with no argument, and return type pointer to an array of pointers. So let me make it. X is a function with no arguments, and return type is a pointer to an array of pointers. So this array also contains pointers. Pointer to what? Functions. When you just have square round brackets, it's a function. Okay, so pointer to functions. So these are also pointer to functions, and for these functions the prototype should look like this. It should have no argument and return type should be double. Cool. So I'll repeat it again. X is a function with no argument and return type pointer to an array of pointers to function with no argument and return type double. Okay, so similar way you can do this also. You can see that particular video there we have covered plenty of examples of such complicated declarations. Fine. Okay, so this is about arrays, and now let's continue with 2D arrays. Just a second. Cool. So we have a practice contest today. I am again repeating it. So this is the link to the contest. CodeChef.com/cpt22021. Okay. Okay. So next is dynamic memory allocation and typecasting. So all the remaining topics. So the 2D array and pointers we'll cover later. We'll see after we finish DMA, typecasting and structures. So there is one video with all the remaining topics. There I have covered 2D arrays and pointers. Okay, so for now let's start with dynamic memory allocation. Okay, so dynamic memory allocation in C++ refers to performing memory allocation manually by the programmer, okay, or at runtime. So when you want some memory basically at runtime, you'll have to use dynamic memory allocation. Okay, so dynamically allocated memory is allocated on heap. So what happens is, in C programming language, when we used malloc, calloc, alloc, reloc, So when you use these functions, so they used to give you some memory in heap, but in C++ we have new other operators as well called new and delete. So these were functions in C, and in C++ new and delete are operators. Okay, so when we use new and delete operators, we get the allocated memory from something called as free store. Free store. Okay, so free store, so they have not defined it properly. Free store can be heap as well. So free store is some memory location which is allocated to the program, but is not used as a stack or anything else. So it can be considered as heap only, as we but in C we called it as heap. So whenever someone asks you malloc and calloc allocate memory from heap, and in C++ when you use new and delete, that allocates memory from free store basically. Okay, so dynamically created memory is located on heap or free store in C++. So the applications are variable length arrays when we don't know the size of an array. Okay, and to create linked list, trees, graphs, etc. Okay, cool. So this is important. For dynamically allocated memory, it is our responsibility to deallocate the memory when no longer needed. So when we have allocated some memory using DMA, it's our responsibility to again free it. So we don't have garbage collector in C++. Okay, so in Java we don't need to do this, but in C++ when we use new operator, we have to again use delete operator. Otherwise memory leak will happen. We'll see next. So in C we did it using malloc, calloc, free and reloc. And C++ support these function and has two new operators, two other operators as well, new and delete. C++ also support this. Okay, C++ is built on C only. Fine, so it supports this also, but it has two new operators, new and delete, that perform the task of allocating and freeing the memory in an easier way. Okay, so operator new acquires its memory by calling an operator new, and delete frees its memory by calling an operator delete. So we'll see the syntax next. Okay, so the new operator. So whenever you write new and some data type t, you will be allocated as many bytes as t wants. So let's say t is int, and int is of size 4 bytes for your system. Then you will be allocated 4 bytes of memory, and you will and this new t will return the address of this memory location. So new and then data type will return the address of this data type, the memory location which is allocated by new, and you can store it in some pointer. The pointer should match the type. Okay, so the syntax will look like this: t star ptr is equal to new t, where t is some data type. So int star ptr equal to new int. Okay, and okay, so this is an example. Fine. Yeah. So this is about new. So we have seen free store versus heap, and okay. So this is not of your concern, but whenever you use new and that particular type t, it automatically calls this particular thing new and then size of t. Okay, you don't need to do this, but internally it will, what it will do, whenever new needs memory on free store for an object of type x, it calls the operator new and size of x. Okay, so in malloc we need to write the size, but here we need not. Okay, just new and then type is enough. Cool. And similarly, when new needs memory on the free store for an array of n objects of type x, it calls the operator this. Okay, so it will automatically call new and n into size of x. So it will allocate, let's say we want n units of type t, n units of type integer, 3 integers, let's say. So automatically it will call new 3 times size of int, so that you get a memory location of size 12 bytes, contiguous memory location, sequential memory. Okay, and you need not write this will be done internally. You need to write like this only. You just write new int and then bracket and then size of whatever you want, and you will get the address of the first memory location of that array, you can store it in some pointer. Yeah. So similarly we have delete operator. So whenever so what happened when you called new and some type t, you were given the address of this particular memory location which was allocated by new, right? And you stored it in some pointer. So this is important, you need to do this, otherwise the returned address will get lost. If you don't allocate it like this, if you don't store it in some pointer, if you just write this statement, the new will be in action. It will allocate a memory location of size whatever t requires and returns the pointer, and you have not captured that particular pointer, so it is lost now. Okay, so this is important, you need to capture it in some pointer. And when you want to free this memory location, you just write delete p. That's it. Okay, so delete pointer, and if you want to delete an array, so you write delete and pointer, square brackets and then pointer. Cool. So then we did some practice question. Again I am skipping them. So they are very important to clear the concept whatever we studied. So it is suggested that you try to do this on your own. I am just running through them for now. So this we have seen, new and delete are operators, malloc, calloc are functions, new allocates memory from free stores and malloc allocates memory from heap. Okay. Then we did some guess the output type of questions. So this is also an important concept. So let me tell this particular concept here. So what happens is when we do delete, so let's look at this code. Here I have an integer pointer and then variable sum, and in this integer pointer I have allocated 6 contiguous integers. Okay, the array of size 6 of type integer, and then I have initialized it. So let's say a memory location of 6 contiguous integers is allocated, and it is initialized to i plus 1 in this loop. So 1 2 3 4 5 6 will go inside that, and the address of this particular memory location is stored in A stores the memory location, the address of this location. Okay, and then we have calculated sum, so that's fine. Let's leave it for now. Now we have deleted this particular A. So what happens is, so if the address was 100, so A will contain 100. Fine. And we have deleted A, so that's fine. So this is just like saying that this particular memory location we don't require it now, so the operating system can use this particular memory block in some other task. So this is what this statement means. But the variable A still contains the memory location 100. It does not delete that. The variable A still contains the memory location 100. So when we again do sum plus equal to AI, so when we again try to address, let's say, A of 0, then again we can get 1. It might be possible. So if so after delete A, when I try to output A of 0, then it is most likely the chance that again I will get 1 only. Even though I have deleted this memory location, still I will get 1 printed. Actually some other value can also be printed. So meanwhile, in between these two statements, if the operating system has allocated this particular memory to some other program and that particular program is overwriting it, then we can get some garbage value as well. We don't know it, so that's very bad thing to happen, right? So we actually don't know what memory location, this memory location is not reserved for us, but we are pointing to it and we are trying to print it. So we don't know what is present in it. So this particular pointer in this situation is called a dangling pointer, A. So A is a dangling pointer. Okay, so we don't know what will happen. Anything can be printed when we are trying to print A of 0. So what is a good practice is, whenever you delete an pointer, a memory location, you immediately assign it to null as well, so that you are restricted to not to use its value now. So now this will be an error. You cannot dereference a null pointer. Okay, so whenever you delete an memory location, you immediately assign it to null as well. So in between these two statements, A is a dangling pointer. Cool. So this was some, so you'll get segmentation fault in it because you cannot dereference a null pointer. A has been assigned null. Okay, so the next concept is typecasting. So you might know it. So this is a very easy concept basically. So for so whenever you have some data types A, B, C, when you have some variables of some data type and you have some operation going on, and for this particular operation only you let's say A is of type character, B is of type int, and C is of type double. Okay, and for this particular operation you want all of them to act like double. So what you can do is you can typecast this, you can do this thing. This is typecasting and C is anyways double. Okay, so for this particular operation the data type of A will not change, it will be character only. For this particular operation A will act like a double. Okay, so for this particular operation 66 will act like as character. So what will happen, the ASCII value of 66, the character, will be printed. So this is typecasting. Fine. So this is the implicit type conversion. So if you are not doing any type conversion, so what happens is whenever you are doing an operation on two variables, and if these two data variables are of different types, so the what compiler will do is allocate a memory location with the size with the data type which has more size. So this is what the compiler feels, that character is bigger than bool, short int is bigger than character, int is bigger than int. This is what it is. What if you don't write anything? This is what that will happen. Okay, so this is called implicit type conversion. So if we have a bool, if we have an int and a long double, if we have an int and a long double, so the precedence of long double is higher. So for this operation both of them will be automatically treated as long double. Fine. So this is what implicit type conversion is. So actually what happens is data loss can occur. Why? Because here we can see that unsigned int has higher precedence than int. So if we have two variables A and B, and one is int and one is unsigned, so for this operation both of them will be treated as unsigned. And if A was negative, so if had it been like this, int A equals -3 and unsigned B equal to unsigned int B equal to 5, and if you are trying to do A plus B, then both of them will be treated as unsigned. So actually A will not be -3 now, A will be that particular value. Okay, so what -3 stores in, so first bit will be 1 and then 2's complement of 3, so that particular big value. So data loss can occur, signs and overflow can occur. So that's why typecasting is important, explicit typecasting is important. Yeah, Nishu, correct. Yeah. So Ritik, both of them are fine. So if you are getting some referrals and everything, then go with off-campus drive as well. But what happens if even if you get into MTech, into IIT for MTech, then you have to learn CP. Okay, I had to learn CP. Even I was doing masters from IIT Bombay, cool. Because in campus drives you have to anyway write the coding test and then sit in interviews. All of the same process repeats for off-campus and on-campus drives. Okay, so you have to be good at programming. Cool. Yeah, so in C++ one thing extra has happened. So this you all know, I know. So this is same as C programming. Okay, you can typecast A to character like this, but also you can do this also. So you can write character and then A. So this is like same as in Python. Okay, Python typecasting works like this, and so you can do typecasting like this as well. So both of them are correct in C++. Fine. So then we had some examples and cool. So let's start with the next concept, structures, unions and enumeration. Okay. So we have already seen arrays and pointers. So these are derived data types. They are derived from the already existing data types like integer, character. We have pointers and arrays on that particular data types. What structure union enum are? They are user defined data types. So you are gonna create your own data type. Fine. Sorry. So what an array was? A sequence of homogeneous data types, right? So a sequence of elements of homogeneous data type. That was an array. All of them must be of type int. So what is a structure? A sequence of elements of heterogeneous data type. One can be int, one can be string, one can be some other structure. Okay, so can be anything, can be any type t. So whenever you write struct and address, you are basically creating a data type. Address will now be a data type. Okay, so address will be a data type, and this data type contains an name, a character pointer, an integer, another a constant character pointer, another constant character pointer, a character array, and another constant character pointer. Okay, so this is an address. This is a data type which has name, address, and this is how this data type looks like. Okay, and now we can define an variable of type address. So if you write address a, then a will be of type address. So a will have all these properties with the names. Names are given in the structure itself. So a will have an character pointer, a will have an integer, and all of these. Okay, so you can write a dot name. So dot will be used to dereference one particular memory location in this data type. So a dot name will be this character pointer. Okay, this is how structures work. Okay, so dot operator is used to reference one particular memory location. And okay, so actually what happens is you can have pointers to data types for any type t. Asterisk t is of type pointer to type t and can hold address of any variable which is of type t. So actually there can be a variable of type t, and let's say t is an structure now. Okay, t is an structure now. So a is of type struct t. Okay, so we can have pointers to pointer to a as well. That will be of type t star. What I am trying to say is, let's say we have a structure t and there are some integer, character, or anything in this. Okay, and we have created an instance of t which has name a. So a is of type t. Okay, so a will have this, let's say integer capital A, character capital B. A will have capital A will have capital B. Okay, and we can have pointer to this particular instance a. So let's say t star ptr equals and a. So we have stored the address of a to some pointer which is of type t star. T is now data type. Whenever you write struct t, t is now a data type. Think of it like integer star ptr. Okay, so we can store anything, address of anything which is of type t. Okay, and now when we want to dereference it, what will we write? Asterisk ptr dot a, right? Just like int. Cool. So actually this particular notation has a shorthand. So this can also be rewritten as ptr hyphen greater than a. So arrow basically. Okay, so ptr arrow a is similar to asterisk ptr dot a. So arrow will use with pointers. Okay, so whenever we are passing in pointer, so what is this? Add is a pointer of type address, address pointer. Okay, and so asterisk address dot name is equivalent to add arrow name. Okay, happy Saraswati Puja, yeah. So what is size of struct address? Yeah, we'll discuss size of struct. So the size of structures are very special concept in C++. Okay, in C we had different things. So in GATE exam you must have written the sum of all the elements present in the structure, but in C++ we have different things. So we have padding and packing. Okay, we'll see those concepts in the last slide. Okay, so we are left with the size of a structure and two-dimensional arrays. Okay, so we'll do that. Okay, so you guys are talking about GATE exam, so yeah, that's nice. Cool. Fine. So yeah, so this is how structures are written, and this is what I am talking about, the packing thing. So when we have one character and one integer and one character, the size of this structure will not be 6 bytes, and instead it will be 4 plus 4 plus 1 plus 1 plus 3 plus 3. So it will be 12 bytes. Okay, so we'll pad 3 bytes extra. So we'll see this concept later. Skip this for now. So the size of structure is not same as the sum of the sizes of all the data types present in it. Okay, cool. And union are similar to structures, but only the size of the maximum data type which is present in it is allotted basically. Okay, so whatever is of the maximum size, that particular size will be allocated, and only one of the elements of a union will be alive at a time, or not all of them. In structures, all of the elements of the structures are alive at one particular time, but in union only one of them will be alive. The last initialized value will be alive. So we'll see with an example what is the difference between. Yeah, so let's say we have an address, and address is a union. Okay, and when we write address.name equals to Samir and address.number equal to 45, what happens is now this name is not alive and this only number is alive. Okay, so you had only one memory location and Samir was somehow written in it, and now it is overwritten to 45. So it will contain 45 and E or something like that. Okay, whatever memory this particular 45 number takes according to that. So this will be the case. So it will be overwritten to 45. So when you trying to print address.number, it will print 45 only. Okay. But Samir is not alive now. You won't have address.name. When you try to print address.name, you won't get Samir now. Fine. Through pointers. So also the through pointers you can use arrow similar to structures. Nah, Pukhraj, I didn't say that the size of a structure will be divisible by 8. So you got it wrong. I said that the size of a structure is always divisible by the size of the largest data type present in it. So in that example, the size of the largest data type was 4, an integer. Okay, so the final size should be divisible by 4, not 8. I didn't say this. Okay, you can see that video. So I will cover this concept again. So yeah, we don't use classes and object at all. So in competitive programming, but coming to interviews in product-based companies, when you are given to design something, then you have to write object-oriented code, right? It will be nicer. Okay, so in some companies in coding test itself, we didn't get competitive programming questions. Instead, we had to do some tasks. So we had to design something, and this particular something has to have some features. So for coding that particular thing, if you write object-oriented code, it would be nice, because they'll see your code in this type of questions. So knowing object-oriented programming and classes and objects would help them there. Cool. Okay, so this is how union works. So size of union is anyway the size of the maximum element present in it. Okay, so there we don't have anything different. And next is enum. So just a second, huh? Okay. Yeah. So next is enum. So enum is also like a structure and union. Here also we create another data type. So when we write enum color, now color is a data type, but the difference here is it can only take values of certain type. So when we write enum color and this, and when we create a variable of type color, then C can only contain 3 values, red, green and blue. It is restricted to contain these values. So these are of type integer only. So red here is equivalent to 0, green here is equivalent to 1 and blue here is equivalent to 2. Okay, so you can assign C equal to 0, 1 or 2, or you can assign C equal to red, green or blue. Okay. So also you can, so these are the default initialization. It will initialize with 0, 0, 1, 2 and so on. If you want to initialize your own values, you can write like this as well. So here now if we create color C, then you can write C equal to 10. Okay, so C equal to 10 and C equal to red are equivalent then. Cool. So then we did some problems on structure and union, and this was a question on enum, the default value of enum. So when we are trying to initialize it, so when we are forcefully initializing it, what happens is we are giving Monday as -1, so that's fine. So what will be allocated to Tuesday? So whatever we are allocating, so if we are allocating the previous enumeration as x, then it will be automatically allocated x plus 1. So Tuesday will be allocated 0, Wednesday we are forcefully allocating 6, so Thursday will be allocated 7, 8 and 9. Okay. Okay, cool. So structures and union and enumeration is done. So now let's join the next meet, the revision meeting 5 I guess, hai na? So revision meeting 5, let's join and meet at 12 p.m. Okay, so we'll cover the remaining basic concepts, and yeah, we shall wrap it up by in 5th meeting only. We'll cancel the 6th meeting. Okay, so just join the 5th meeting at 12 p.m.